Okay, why is it picking up that? Oh, interesting. That is... Okay, hold on. Wait, where's... There it is. Okay, sorry about that, guys. It is still pretty early. Is it focusing? It is focusing. Fantastic. We're gonna do the old switcheroo here real quick.
Welcome to Jeremy's IT Lab. This is a complete course for the CCNA.
Sorry, we are not.
Network Associate. In this video, welcome to Jeremy's IT Lab.
Oh my gosh. Okay, hold on. I thought I was ready, and then because I was trying to do something different where I use web browsers instead. But honestly, I think it's gonna be so much easier if I just have my screen. So we'll put this here. And I have a fourth monitor now. So it's a little different. Okay, let's... Okay, now we're starting to cook with gas. And then we'll close this because we don't need that. Okay. So here's what we're gonna do. Okay. If you've been with me, if you've watched any of my study streams before, we go over like networking, IT type stuff, things like that. We are going to, it is summertime, school is out, and we are going to slowly get ourselves going here. We're going to review, we're going to use Jeremy's Tech Labs right here, IT Lab, in order to kind of learn and kind of figure some things out. I also have Anki in here as well. Where did that go? That should be... There it is. Boom. I also have Anki here that we'll be able to use. Yeah, I might come up with some type of format or something. It's gonna be different than if you watch any of my other networking streams where I did like the networking plus where I had like the chatbot GPT and then I had like the questions and stuff all up inside. I'm gonna try to do a very similar thing. However, it's definitely different. I don't have the same type of study materials as we had before. But we are gonna watch this, and we'll watch it continue to do the course. We'll also watch this. Playback speed. Because I can't stand when things are like the normal playback speed. Actually, can we just make this full screen? What does that do? It does that, and then I'll hide Anki. We'll figure out Anki. That makes it worse. Okay. Alright, well, here's what we're gonna do instead. Sorry, I was I'll try something real quick. last ditch effort. Yeah, that should have been it. I should have been able to capture that. Okay, well, it's not letting me capture my entire screen for some reason. I don't really understand why. There it goes. Nah, that's fine. And then we'll move it under. So what happens if I then bring Anki on, but then I also open Anki? Okay. Okay, it's going to be a little bit of like finagling, trying to figure things out.
Wow, my microphone hasn't been on the entire time. Fantastic. Okay, well, anyway, we're going to go ahead. God damn it. Okay, we're going to go ahead and we're going to get started here.
Welcome to my complete CCNA, Cisco Certified Network Associate course. This is Jeremy's IT lab. Since this is the first video, allow me to introduce the course. This course aims to be a complete course for the CCNA, including everything you need to pass the exam, all 100% free. There will be lecture videos covering every topic on Cisco's official exam topics list, practice quizzes covering the material in each lecture, flashcards to help you review and remember what you learned, practice labs using Cisco's network simulation software Packet Tracer, and at the end, multiple practice exams to get you ready for the real thing. Although this course will be based on Cisco's official exam topics list, I also want to give you extra information to improve your understanding of networks in general. That additional context should also help you understand the exam topics. Because this is the first video in the series, I want to talk about who this course is for. This course is for anyone who wants to pass the CCNA 200-301 exam. At the time of recording this video, this is a new exam. So, what is a network? Let's ask our friends at Wikipedia.
We should already know a lot
A computer network is a digital communications network which allows nodes to share resources. Well, if you didn't understand before, you probably still don't after reading just that. Let's look further. The definition states that a network allows nodes to share resources. What is a node? I'll introduce some types of network nodes here, some of which appeared in the sample network on the previous slide. This is a router. You've probably heard the word before and have a general idea of what a router is, but I'll explain a router's function in this lesson. Next, this is a switch. Maybe you're familiar with what a switch is, maybe not. It serves a different function than a router, but is also similar in many ways. This next one is a firewall. You're probably familiar with firewalls, and
if you have a hard time remembering the difference between these three things, I think of it in terms of this allows me to talk to people outside my house. This allows me to navigate traffic with inside my house. And this is a firewall that, I mean, obviously that just helps with security and can be on the router or on the switch.
you most likely have a firewall installed on your computer.
Usually.
That's a software firewall. But large networks usually have a hardware firewall, a separate network appliance, which helps protect the network. This next symbol represents a server. If you know computers, you surely have heard of servers before. What exactly do they do? Well, if you're watching this video, you're getting it from a server on the internet. The last symbol on this slide is a client. You're using a client to watch this video, whether it's a smartphone, a laptop, a desktop PC, or whatever. What exactly is a client? Let's get into it. Over the next few slides, let's build a sample network and look at the functions of each of these network nodes in the network. You might also hear clients, as well as the previous node type servers, referred to as end hosts or endpoints. Okay, so we looked at some types of network nodes, but we didn't really examine exactly what each type of node does in a network. Let's build a network and examine each node's role. So, here we have two PCs, PC1 on the left and PC2 on the right. As is, this isn't a network. However, if I connect them together with a cable, we now have a network. That's right, two PCs connected together actually makes a network. Now, it's a very simple network, but if we take a look at that Wikipedia definition once more, a computer network is a digital telecommunications network which allows nodes to share resources. Now that these two nodes are connected, they can share resources and essentially have a conversation with each other. Now, I'm representing clients with this symbol, but there are all kinds of devices which can be network clients. For example, a laptop, or desktop PC running Microsoft Windows, or how about an iMac running Mac OS? or even an Apple iPhone running iOS. These are just a few examples of devices which can be network clients. So let's give a simple definition of a client. A client is a device that accesses a service made available by a server. Okay, since server is part of the definition of a client, to understand one, you have to understand the other. So, what's a server? Let's take a look. I use this symbol to represent a server. When you think of the word server, you may think of something like this IBM server, or this Dell server.
Man, that's cool.
And indeed, these are powerful servers, and you'll see rows and rows of servers like these in data centers. However, not all servers look like this. In fact, any of the clients we looked at in the previous slide can be servers too. How is that possible? Well, let's look at the definition of a client again, and then compare it to the definition of a server. The definition we used for a client was, a client is a device that accesses a service made available by a server. So we can basically reverse that definition to know what a server is. A server is a...
This is how you can have your own server, like on your, like in your house as well too. Like if you have an old PC just laying around, you can connect it to your network and you can make it visible. It's not very hard to turn it into an actual server.
device that provides functions or services for clients. So let's look at the simple network of two PCs connected with a cable that we saw before. Remember this network? Watch this little exchange between the two PCs, and think which of them is the server and which is the client. PC1 asks PC2 for the file image.jpg. PC2 responds and sends the requested image file.
Isn't that crazy?
So which is the client and which is the server? Well, PC1 is the one requesting the service, requesting for the image to be sent. And PC2 is the one providing the service, the one sending the image. So that makes PC1 the client and PC2 the server. Let's look at another example of a client-server relationship. On the left is your computer, or perhaps your smartphone, whatever you're using to watch this video. On the right is a YouTube server, which contains this video. What do you think the blue cloud in the middle represents? The answer is the internet. In network diagrams, a cloud is often used to represent the internet, or in any situation where the details of that part of the network aren't necessary. The internet is a very complex network, and for the sake of this diagram, all we need to know is that data from your computer passes through the internet to reach the YouTube server. The exact details of the internet aren't important for this diagram, so we can simply use this cloud to represent the internet. So, your computer sends a request to the YouTube server for this YouTube page, including the video. And YouTube server sends the data passing through the internet back to your PC. However, YouTube doesn't send the data all at once. It sends you a stream of data until you've watched the whole video. For one more example, let's say you want to get a video from your friend. You both have iPhones, so you ask him to send you the video by AirDrop. Your phone requests the video, and his phone responds, sending the video. You probably know it by now, but which phone is the client and which is the server?
Yeah.
As you probably guessed, your phone on the left is the client, and your friend's phone on the right is the server.
Whoever's asking is the client.
To review once more, a client is a device that accesses a service made available by a server. And a server is a device that provides functions or services for clients.
Yep.
Also, keep in mind, the same device can be a client in some situations and a server in other situations. Okay, hopefully you have a better idea of what a client is and what a server is. Now let's build out the network further and show the next part of the connection between end hosts and the internet. Let's say this is a network for an enterprise, and this enterprise has a branch in New York and a branch in Tokyo. Of course, a real enterprise branch will have more than just a couple PCs or a couple servers, but I also couldn't fit an entire network on this one slide. Now, typically, you don't connect end hosts like PCs or servers directly to each other. You aggregate the connections to a device called a switch. As you can see, the two PCs are connected to switch 1, and the two servers are connected to switch 2. Switches have lots of interfaces for you to connect end hosts to. Look at this Cisco Catalyst switch. As you can see, lots of interfaces or ports to plug your PCs or servers into. Switches are used to forward traffic within a LAN, a local area network. PC1 and PC2, as well as other devices plugged into switch 1, such as a network printer or another PC, all reside on the same local area network. The same goes for any devices connected to switch 2 in the Tokyo branch. So, we have one LAN on the left and one LAN on the right. The hosts within each LAN can send data to each other, for example, PC1 to PC2. However, these switches cannot connect directly to the internet and send data between the two LANs. So let's talk more about switches. Here on the left is the same Cisco switch from the last slide. It's a Catalyst 9200 model switch. On the right is a Catalyst 3650 model switch. Catalyst switches are Cisco's enterprise-grade switches, used by many enterprises to connect their LANs. Now let's review some characteristics of switches. Switches have many network interfaces or ports for end hosts, such as PCs, to connect to, usually 24 or more. Switches provide connectivity to hosts within the same LAN, meaning local area network. We'll cover the details of LANs later, but for now, just know it means end hosts within the same area, like a bunch of computers on one floor of an office, or perhaps an entire small office or your home network. Finally, switches do not provide connectivity between LANs or over the internet. To do so, we need another kind of network device. That device is a router. We can connect the switches to routers like this, and then connect the routers to the internet. When end hosts in the New York branch LAN want to communicate with end hosts in the Tokyo branch LAN, they will send the data to their router, R1, which will then forward it to the Tokyo branch LAN via the internet. For example, if PC1 in the New York branch wants a file on server 1 in the Tokyo branch, it will send the request to R1 via switch 1, which will then forward it over the internet to R2, which will then send it to server 1 via switch 2. The reply will then follow the reverse path back to PC1. So, let's talk about some of the characteristics of routers. These are a few examples of Cisco routers you might find in use in an enterprise network. The ISR 1000 and ISR 4000 have their network interfaces on the back, but if you look at the ISR 900, you can probably notice a difference between a router and a switch. Let's bring up one of the switches we looked at before. Compared to this Catalyst 9200 series switch, the ISR 900 router has relatively few network interfaces. That's one characteristic of routers compared to switches. Routers have fewer network interfaces than switches. Also, remember that switches are used to forward data within a LAN. Routers do the opposite. Routers are used to provide connectivity between LANs, and because of that, routers are therefore used to send data over the internet. Here's our network once again, but this time there's a difference. There is an attacker somewhere in the internet, with an arsenal of many ways he could attack our networks to steal information or otherwise damage our enterprise. Although routers can also provide some basic security features, what we should really be using to protect our networks is a firewall. Firewalls are specialty network security devices that control network traffic entering and exiting your network.
Firewall doesn't have to be
Firewalls can be placed outside of your router, like Firewall 1, or inside of your network, like Firewall 2. What's important is that they protect the end hosts inside, like the PCs and servers in this network. Firewalls must be configured with security rules to determine which traffic should be allowed and which should be denied. If you configure the rules properly, if PC1 in the New York branch tries to access server 1 in Tokyo, the firewalls should permit the traffic through. The return traffic from server 1 to PC1 should be allowed as well. However, if the attacker tries to access anything inside of our networks, the firewall should block it. So let's look at a couple of Cisco's firewalls. At the top here are two examples of Cisco firewalls. On the left is an ASA 5500X series firewall. The ASA, or Adaptive Security Appliance, is Cisco's classic firewall. Although the ASA is their classic firewall, modern ASAs include modern features of so-called next-generation firewalls, including things like IPS, or Intrusion Prevention System. You'll hear a lot more about that in the security section of this course. On the right is a Firepower 2100 series firewall. This is a next-generation firewall as well. Okay, let's review some characteristics of firewalls.
Version 2 of the CCNA test is
Firewalls monitor and control network traffic based on configured rules.
10% about it is
You explicitly configure which network traffic should be allowed into your network and which should not.
How that's going to affect
Firewalls can be placed inside the network or outside the network, meaning the firewall can filter traffic before it reaches the router or after it has passed through the router. In some cases, you might have a firewall inside and outside the network. Firewalls are known as next-generation firewalls when they include more modern and advanced filtering capabilities. Both of these Cisco firewalls are considered next-generation firewalls. Now, I have one more thing to look at regarding firewalls. What about the firewall on your computer? Let's take a brief look. The two firewalls we looked at in the previous slide are network firewalls. Network firewalls are hardware devices that filter traffic between networks. These are the kind of firewall we will focus on in this course, as it is a networking course. However, there are also host-based firewalls. Host-based firewalls are software applications that filter traffic entering and exiting a host machine, like a PC. Your PC almost certainly has a software firewall installed, as it should. Even in a network with a hardware firewall, each PC should include a software firewall as an extra line of defense. Okay, now we're back to our definition of a network. Do you understand more about each of these types of network nodes? Keep in mind, there are other kinds of network devices, and we'll cover some of those later in this course. Stay tuned for this lecture's supplementary materials, which will help you review and test your knowledge. In the next lecture, we will look at the next two sentences of this Wikipedia definition of a computer network, focusing on the various kinds of connections between these network devices. For For this lecture and all other lectures, there will be supplementary materials to help you practice and improve your understanding. There will be free primary resources. End of video quizzes after each video.
Yeah, that's
This
what
video's
we're
quiz
gonna
will
do.
be coming up right after this slide. There will also be pre-made flashcards to review the lecture's material, using the flashcard software Anki. These flashcards will be included in the description of each video. Since this is the first video, however, I will make a separate video explaining how to download and use the Anki software. If you already know how to use Anki, feel free to download this video's flashcards in the description and get started. Otherwise, wait for the next video and I'll show you how.
Studying.
Just one recommendation.
Also
As I will upload
failing
a
at
separate
OBS
flashcard
'cause
deck
I'm
for each
trying new
video,
things.
instead of having many separate decks, I recommend you create one CCNA deck and then transfer the new cards to that central deck. Finally, there will be a practice lab using Cisco's network simulation software Packet Tracer for each and every video. I will release separate videos for these practice labs, and will include the Packet Tracer file in the descriptions of those videos so you can download them and complete them yourself. The Packet Tracer lab for this video will be a demonstration of how to download Packet Tracer and get started with it. Now, let's go on to this video's quiz. Select the best answer from the available choices.
This is
In
what
some
this is
cases,
what I was
there-
looking for. This is what I was looking for. Yeah, I'm super big loser, big time loser. I just relearned how OBS works with like collecting different browsers and stuff. And I realized that I've had it set up not correct this entire time. And that's why I don't know if there's been music playing or not. Don't be anything incriminating. Okay, good. No, actually, I am not exempt. I am the exact opposite of being exempt. There has been music. Okay, well now that's playing through this, I got a fourth monitor. I say that I'm just using my tablet as a monitor. What? Oh, good. It's
Evil mastermind has set up.
yeah. Yeah. Okay, so now there should be music, right? Well, there should have always been music, but now I can control it. Before I wasn't able to control it, now I can control it. So let's put it here.
Are multiple answers that could possibly be correct.
Yes. Okay, sorry.
But there will
about
always
that.
be one best
So let's
choice.
answer these questions.
Cisco exams tend to have lots of questions like that, so hopefully some of these will be able to test you in a similar manner. This first video's quiz questions, however, shouldn't be too difficult.
It should be
Your
really
company wants to
easy,
purchase some
actually.
network hardware to which they can connect the 30 PCs in your department. Which type of network device is appropriate?
Oh, they
A,
want to
a
connect
router.
30 PCs
B,
in the
a firewall.
department. It's gonna be a
C,
switch
a switch. Or D, a server.
because
Pause
it's
the video to
in-house.
think about your answer.
In-house.
The answer is C, a switch.
Yep.
Let's analyze each of the incorrect answers first, then the correct answer. A router, like the Cisco ISR 900 series router, is designed for forwarding traffic between networks, not for connecting lots of N hosts like PCs to. Also, a router would not typically have 30 network interfaces to connect hosts to. So A, a router, is incorrect. A firewall, like the Cisco ASA 5500X series firewall, is designed to filter traffic as it enters and exits the local network. It is not designed to connect directly to end hosts, and typically will not have enough network interfaces for 30 hosts. So B, a firewall, is incorrect. A server is an end host itself, not a networking device to which you will connect other end hosts. So D, a server, is incorrect. A switch, like the Cisco Catalyst 9200 series switch,
Oh no,
is
we're
designed
not
to connect many
talking
end
about
hosts in the same
stealing
LAN
Gmail
together.
right now.
They include many network interfaces to connect hosts to. So C, a switch, is the correct answer. Okay, let's go on to the next question. You received a video file from your friend's Apple iPhone using AirDrop. What was his iPhone functioning as in that transaction? A, a server. B, a client.
Oh, the
Or C,
iPhone's
a local area network.
is being
Pause the
treated
video
as
to think about your
a
answer.
server.
The
Yeah.
answer is A, a server.
Yeah.
Let's check the
Because
answers.
it's giving information.
In this case, your iPhone, not your friend's iPhone, is functioning as a client. A client accesses a service. It does not provide a service. So B, a client, is incorrect. An end host like an iPhone does not function as a local area network, LAN, by itself. It can, however, be a part of a local area network. So C, a local area network, is incorrect. A server is a device that provides functions or services for clients. In this case, your friend's phone provided the file to your iPhone. So A, a server,
Yes.
is the correct answer. Let's go to the next question.
I really like this guy.
What is your
I'll show you
computer or
guys
smartphone
how I
functioning as
found
while you
him
watch this
in
video?
a second.
A, a server.
Because when I
B,
first
an
hold
end
on.
host.
What is your
Or C,
computer or
a
smartphone
client.
functioning as while you
Pause the
are
video to
watching
think about
this
your
video?
answer.
It's acting as a client because I'm receiving the information. I'm
answer
asking for
is
the
C,
information.
a client.
Yeah.
Let's check the answers.
I'm going to show you guys how I made
device is
or
receiving
how
a
I
service,
found this
not
guy and
providing
how
one.
I made my
So it is
study
not functioning
routine
as a server.
and stuff
Therefore,
and how
A,
we're going
a
to follow
server,
it and
is
whatever.
incorrect. Although your device is an end host, that does not describe its function. Both servers and clients are end hosts in a network.
Yeah.
So B, an end host, is incorrect.
An in-host is the end
Your
of
device is
the
receiving a
network.
service from
It's
YouTube
the end of
servers.
the wire.
Therefore,
So
it is
like
functioning
if I
as a
have two
client.
computers
So
that
C,
are
the
connected,
client is the correct answer.
both of them are
Let's go
end
to the next
hosts
question.
because it's the end of the wire.
Your company wants to purchase some network hardware to connect its separate networks together. What kind of network device is appropriate? A, a firewall,
Company wants to
B,
purchase some
a
network
host,
hardware to
C,
connect
a
its
LAN,
separate network.
or D,
Oh,
a router.
A router.
Pause the
'Cause
video to think about your
it's
answer.
connecting separate individual pockets. So like
The
my
answer is
house
D,
and my
a
neighbor's
router.
house.
Let's check. Although a firewall can connect multiple networks together, its real purpose is to monitor and control traffic as it enters and exits the network. So A, a firewall, is
Firewall
not the best
will
answer.
have a few.
The term host can refer to any type of network node. So B,
Hey,
a host, is
50
incorrect.
acres of land up North Texas.
LAN
above
stands for local area network.
Huntsville.
A LAN
Pretty
is not a
cheap.
network device itself. So C, a LAN, is incorrect. A router is a device that is designed to connect and forward network traffic between multiple networks. So D, a router, is the correct answer. Let's go to the final quiz question for this video.
All right, let's do it.
Your company wants to upgrade its old network firewall that has been in use for several years to one that provides more advanced functions. What kind of firewall should they purchase? A, a host-based firewall. B, a next-level firewall.
A next level
C,
firewall.
a
Oh,
next-generation firewall.
Next generation.
Or
Firewall.
D, a top-layer firewall. Pause the video to think about your answer.
Ooh. We're not very good with firewalls.
The answer is C, a next-generation firewall.
That makes sense.
Let's check each answer. A host-based firewall is a piece of software that runs on an end host,
See, that's what I
like the
thought.
firewall on your computer. It is not a network firewall. So A, a host-based firewall, is incorrect. Next level and top layer are not actual types of firewalls. So B and D
See?
are incorrect.
That's what I thought. Those other
A
ones
next-generation
were,
firewall combines traditional firewall
firewalls.
features with more advanced filtering functionalities.
Waifu coin. Actually,
So
we're not
C,
listening
a
to Waifu
next-generation
music. We're
firewall,
listening
is correct.
to Lo-Fi Boy.
Thank you for watching. That's all for this video. If you want to show your support, please subscribe to the channel.
Yeah,
like the
definitely
video,
subscribe to
leave a comment,
Jeremy's IT
and
Lab.
share the video with
Like,
anyone else studying for the CCNA.
Really, really good.
I also accept donations via cryptocurrency or Patreon via the links in
He
the description.
accepts cryptocurrency.
That's all for now.
You know? Okay. We're just gonna stop that right there. So some things that are going on. Yeah. We're gonna move this over here, and we're gonna open up the next one here. So basically, this is what I did, okay? Because I needed to get my CCNA certification, and I was like, okay, well, like, how am I gonna do this? How am I gonna study? Because it's not as straightforward in terms of study material as it was with the Network Plus. I've already taken CCNA 1, 2, and 3, so like I already have a lot of the knowledge, but it's been at least 10 months since I've actually like done any CCNA stuff or anything like that, because I was a school teacher, I was doing things, I wasn't able to really like keep up with my skills or anything like that. So actually what it ended up doing was I went to Claude and I said, hey Claude, I'm making like these things. Can you, I want to get my CCNA. I need to get it taken. How do I access my Netacad? How do I do these things? And I basically just kind of worked it through, sent it screenshots of my stuff, and then it gave me a study plan. I gave it access to my calendar, so that way it was able to create like calendar things in my Google Calendar. I'll show that in a second as well too. And then it came up with my final CCNA roadmap, which I have right here. And this is the roadmap that we're going to follow through the study. I really wanted it to be only a 10-month or a 2-month thing, but it just isn't going to happen. So here's the CCNA, and this is to get certified before February, because February 2027 is when the new, it's when the new comes out, the version 2 of the CCNA. And that's where it has a bunch of troubleshooting and a bunch of AI stuff or whatever. But I didn't want to wait. That seemed like a bad idea to wait from now into February and then buy more testing materials and do whatever. I was like, no, bro. Like I'll just study, get it now, get it in like September or August, and then move forward from there. So 6 hours a week. So we're gonna study every Monday and Wednesday. At 7:30, 8 o'clock, kind of depending on things. There's going to be a total of 32 study sessions and 4 phases of each one, and then the exam. We're not going to go through all of this. I just thought that this was really good. It helped out considerably. It gave me actual links. It linked in the labs and the things that I needed to do. The Jeremy's IT lab, huge deal. Helped out considerably. And then it even links me because he has it broken down into day 1, day 2, things like that. And what I did from there is, because I told you guys I gave it access to my my calendar. Let me make sure I don't incriminate myself. I don't know. Can I move this? Wow, I can do that. I want to show this, but I don't want to show you guys the rest of my life. So let me... Is that going to work? Okay, now I remember why I was doing that. Okay, we should be... No. Well, I already doxed myself. The point is that it made me the calendar invite, and it put the links and everything like in there as well. So now it's all on my phone. I'm able to like watch the videos, listen to them on my drives, and all different types of stuff like that. So that's our study plan. This is what we're trying to do. Phase 1 is the fundamentals. Phase 2 is switching. Phase 3 is enterprise. So basically like CCNA 1, 2, and 3, right? And then phase 4 is test prep, exam prep, and really refining it. I probably don't need, I personally probably don't need a lot of these reviews, but like I said, it's been a very long time, so we're gonna follow the process and we're gonna go through it. Yeah. Whoa. I am not. Whoa. Definitely not used to certain things. Okay, I don't need this, and I don't need this. I barely need that. Okay. And I'm going to come up with a better solution to how things should run. We're not going to watch this whole video here. We are going to watch some of it because it talks about Anki and how to download it and things like that. Basically what you're going to do is you're going to click on his free flashcards, which is going to open up his, and these are the flashcards that I'm going to use as well. And you're going to open it up and you're going to type in your first name and your email. This is not him farming you for information. This is, he's going to email you like the download for it. Okay. And then here is how to get Anki as well. Anki uses something called RSS. He'll talk about it a little bit in the video. RSS is like a free thing that allows you to scrape information and put it somewhere else. So without me doing a horrible job, let's watch a little bit.
Look at one of the supplemental resources I provide for this course, Anki Flashcards. For most lecture videos of the course, I will provide a deck of flashcards that you can open in the Anki app. These flashcards will help you review and remember important information covered in each lecture. Anki is an example of SRS,
Yes, SRS.
spaced repetition software. It allows you to create flashcards,
This is
as
how
well as
True Gamer
import
Score is
pre-made
built too, by the way.
flashcards such as the ones I provide. Anki's algorithm schedules flashcard reviews for you each day to help information stay in your long-term memory. You don't have to use the flashcards for this course, but I highly recommend that you try them at least. So this is the Anki homepage, apps.ankiweb.net. If you want to really learn how to use Anki well, you can click on the docs link up here to read their. Once you install
Anki, it's gonna look super funky, because it opens up like a terminal, and that's how it like downloads itself and whatever. It kind of looks like you're downloading malware for whatever reason, but when you get it downloaded, it should look like this. Yeah, there we go. That was odd. I should not have messed with that. Why must I mess with things? Anyway, so that's what it looks like. We have different things that are going on here. We have our flashcards, one for network devices, and then day 2 flashcards for interfaces and cables. The interfaces and cables are going to be way more intense. This is a deck, and these are sub decks. They're in it, so he'll talk about that real quick, because I don't really want to re-download this and go through this whole thing. Where is it? Most, yeah, here we go. So he'll give you his access to all of his stuff. Now he doesn't just give you access to the Anki. He also gives you the packet tracers as well. So I have all of that in a nice little folder somewhere. Yes, there it is. Okay. Just trying to help you guys.
And actually, you won't be able to sign up multiple times if you try.
So that way, it's just trying to
The
help you
email
guys. So that
system
way,
I
if you
use
want to
will only
follow
send
along
each
with the
email to
studying.
each address once. I highly recommend bookmarking this Google Drive so you can access the files easily. For this demonstration, I've downloaded the flashcards for day 1 and day 2. Here they are in the folder. To import them into Anki, you can simply click on the files. I'll import day 1 by clicking on it, and click Close on this notification, and then do the same for day 2. Now both decks are imported into Anki. Notice next to each deck there is a 20, indicating that there are 20 new flashcards in these decks to learn today. Here's my
the
first
link of this
recommendation.
video is in the
Increase the maximum number
video.
of daily new cards and reviews.
All links of
To
all
do
materials
that,
are in
click the
description.
gear icon for either of the decks. Notice that the default settings for new cards per day is 20, and maximum reviews per day is 200. I don't want Anki limiting my new cards or reviews, so I'll just increase these to 999 and 9999, and click on Save. Now notice that the Day 1 deck has 22 new cards, and the Day 2 deck has 57. Those are the actual number of cards in each deck. Before, the number of new cards Anki would show was limited by that setting. Of course, you don't have to increase the limits, that's just what I do. My recommendation is to make the flashcard decks for each day of the course sub-decks of this CCNA deck we made earlier.
Yeah, basically like
To
it
do
becomes
that,
like a folder.
click on the deck name and drag and drop it onto the CCNA deck. I'll do it for both decks. Now the CCNA deck has 79 new cards ready for us to learn. But if I click on the plus icon next to the deck name, I can see the individual sub-decks. So this gives more flexibility in learning and reviewing cards. If you want to review flashcards from all days of the course at once, you can click on the CCNA deck. But if you just want to review cards from a particular day of the course, you can click on that particular deck. For this demonstration, I'll just show the Day 1 cards. To review cards in a deck, click on the deck's name, and then click on Study Now. So
this is where the cool part comes in. is that if I click on the, so you see how it says new and it says learn and then it says do. So as you go through the flashcards, I can hit start study now. It's gonna give me a flashcard and then it tells me was it should I do it again? Like, was it really hard? Was it good or was it easy? And that's gonna tell you how often it's going to make that certain flashcard like pop up. So here's the meta of what we're gonna do. Where is? Yeah, there we go. Okay, so here's my prompt for GPT. In this thread, I'm going to be studying. Oh, that should be so I guess solely studying. Yeah, whatever. My CCNA certification. I'm using Jeremy's Tech Labs. Here are the videos that I'm going to watch, and then I gave them the videos that I'm watching. This thread is going to be called Day 1 thread. When I ask a question, I want you to simplify the answer, give me an analogy, give me a more in-depth answer, and then a real-world answer. And then it was like, do you understand? And then it just regurgitated back. If you're not using AI in order to study, then like you're gonna get beat. You're already losing. The way I view AI is that it's like going Super Saiyan. Like at some point in Dragon Ball Z, Super Saiyan became like the default. They never fought anyone without them being Super Saiyan, basically, unless they were just like toying with them, kind of thing. So imagine like me and you are competing with each other. We're trying to take the CCNA, and you decided not to use AI, but I did. I have like a 50+ multiplier, and you don't. Like, I'm gonna beat you every single time because it's like your own personal teacher. Now, you don't have to like pay for it or anything like that. I do, but you don't have to. And just so you know, when you're using AI in order to learn, in order to study, you have to treat it like a high school kid. You have to constantly ask it for clarity. Do you understand what I'm asking you to do? And then you yourself have to be extremely clear with what it is. It's not just context. You have to be clear with what your intentions are. Okay? It's almost like you're taking them on a date or something. Like you have to make sure that you are extremely clear with what it is you're going to do and how you're going to do it. This did not update. That's interesting. If I hide it and bring it back, is it? That's here. Let me remove it and then pull it back because something broke with it. Wow, it like removed it. Wow. It like totally crashed. It wasn't Anki that crashed. It was OBS. So let's go to window capture. We'll call it Anki again. And we'll go here. I don't know why there's like this little black thing right there, but whatever. It still isn't picking it up. Interesting. Very interesting. I didn't know that it was going to do that. That means in order for me to show this, yeah. Weird. Okay, we'll remove it, and we have to go to this, which sucks because that means that's like way smaller in order to get this here. I'll have to figure that one out. I don't know what's going on with that. So then you go back to Dex, you just click this, and it should tell you what's going on. So, man, that's Let me try one more thing. It could just be the program too. There it goes. Yeah, because I would much rather it be that because that's way bigger. Okay, now we look way better. We look way better. Is it gonna work now? Negative. Negative. It does not change. That's so odd. Yeah, it doesn't even register that I'm clicking on things. Wow. Okay, well that sucks. Nothing else I can do about that other than going to display. We will remove that indefinitely. We'll open this up and then we'll go through some of these cards. Yeah. Okay. Well, my apologies. And there's not a lot I can do about that. No, I don't. Windows, I don't want you to do that. Just be here and be chill. Okay, well, let's do it. A blank provides connectivity to a host within the same LAN. Okay, within the same LAN is the key word here. The answer is switch. That is the answer. Yep, answer is switch. That was pretty easy. However, I want to run through these a lot, so I'm just gonna hit good. What does this symbol mean? That is firewall. A firewall which combines a traditional firewall with more advanced filtering functionalities is known as a firewall next generation. Bruno. Yep, next generation. No, Boruto. I don't know if I said Bruno. Okay, a blank is a device that accesses a service made available by a server. It's not client, it's the other one. It is... What it is not client, it is... Oh, it should be server. A blank is a device that is accessible... that accesses a service. It's client. What does LAN stand for? Land access, or large access network. Oh, local access network. I should have known that. We'll do that one again soon. Okay, a blank is used to send data over the internet. A Ethernet cable. Oh, a router. That's what it meant. Duh, we didn't even talk about cables this go around. A computer network is a digital telecommunication network which allows blank to share resources. Nodes, server point, endpoints, server, nodes. Blank and blank are also known as in-hosts or endpoints, clients and servers. Yeah, because it's the endpoints of the cable. That's a switch. A blank monitors and controls network traffic based on configured rules. Oh, monitors. It's probably a firewall. Yeah. What does LAN stand for? LAN stands for local access network. Hey, look at that. Look at that. Blank is used to send data over the internet. Router. That is a server. Blank is a device that provides functions or services for clients. Blank is a device. That provides service. That's a server. Yep. All right, we're doing pretty good. Got 9 more. 9 more. That's what it says down here. Okay. What kind of network device is a Cisco ASA? Isn't that a firewall? I don't remember what is yeah. What is a Cisco ASA? Yes, that's what I'm talking about. That's what I want. Yeah, this first day is going to be pretty easy.
Two, analogy. Imagine a company building with a front security desk. The security guard checks who is trying to come in. Where are they coming from? Are they allowed inside? What room are they trying to access? Are they suspicious? That is basically what a Cisco ASA does for network traffic. For example, a user inside the company wants to visit a website. The ASA says, this is inside to outside web traffic. That is allowed. But if a random device on the internet tries to connect directly to an internal company computer, the ESA says, nope, that is outside to inside traffic. And it is not allowed unless there is a rule permitting it. 3. More in-depth answer. A Cisco ASA is a dedicated security appliance used as a firewall, and often as a VPN device. It commonly performs functions like firewall, filtering. It uses rules to decide which traffic is allowed or denied. Stateful inspection. It keeps track of active connections. So if an internal computer starts a connection to a website, the ASA remembers that connection and allows the return traffic back in. NatPat. It can translate private internal IP addresses into public IP addresses, so devices can access the internet. Example, internal PC, 192.16.8.1.1. Public internet address, 203.0.113.5. The ASA can hide many internal devices behind one public IP. VPN, support. It can create secure encrypted tunnels for remote users or branch offices. Examples, remote, worker, VPN. Site-to-site VPN between 2 offices. Network segmentation. An ASA often separates networks into security zones, such as inside, outside, DMZ.
Yes, DMZ.
A DMZ is a semi-public area where servers like web servers live.
Demilitarized zone.
The ASA can allow internet users to reach the public web server while still protecting the private internal network. In CCNA terms, you can think of the ASA as a device that sits at the network edge and enforces security policy between different networks. 4. Real-world scenario. A college has an internal network with staff computers, student systems, printers, and servers. They place a Cisco ASA between the college network and the internet. The ASA allows staff and students to browse the web, internal devices to receive return traffic from websites they requested, remote workers to connect through VPN, public users to access the college website in the DMZ. The ASA blocks random internet users trying to access internal PCs, unauthorized inbound traffic, suspicious or unwanted connections, traffic that does not match the firewall rules. So in a real help desk or network admin environment, the Cisco ASA is one of the devices protecting the organization from outside traffic while allowing normal business traffic to work.
Okay, cool. 8 more. A blank has many network interfaces for end host to connect. Oh, a switch. I forget that these are super basic. Routers have blank network interfaces, then switch. routers have blank network interfaces than a switch. They have less. Fewer, yeah. That is a router symbol. Can a single device be both a client and a server? Absolutely, your phone can do that. What kind of network device is a Cisco ISR? Isn't that a next-gen... Isn't that a next-gen firewall? No, it's a router. Let's look this up. There's no need to ask AI this. I just want to see it. Give me a picture. I want to see an image. Yeah, there we go. Look at that. A face only a mother could love. Okay. A blank is used to send data over the internet. A router. What does LAN stand for? LAN stands for local access network. Area network. Dang it, dude. I always think it's access. What? There we go. And next. What kind of network device is a Cisco firewall? Firepower. I'm assuming it's a firewall, but I've never heard. Did he talk about that in the video? So, yeah, it's a firewall. I mean, why in the world would it be named firepower if it wasn't a firewall? That's kind of silly. Okay. What kind of network device is a Cisco ISR? What does ISR stand for? It's a firewall. We know that. Wait, I already did this. Integrated server router. Interesting. I didn't ask this one because I asked Google because I just wanted a short answer. I didn't want a long drawn out one from GPT. Which routers are designed? Router switching, LAN, security built in. I know that, but what is integrated? What is integrated about it? Service. It's called integrated because it combines multiple separate network functions into one single device. Interesting. Built-in core services, routing, switching, security, voice, computing. Wow, so it does a lot of things. Even does voice. So I'd imagine then that this is the thing that this is the router that a lot of schools probably use then, because it's kind of like an all-in-one almost. That is a firewall. What kind of network device is a Cisco Catalyst? Ooh. I'm gonna say router. Oh, it's a switch. That symbol is a... Oh, it's a client. A blank proves connectivity to host within the same LAN. Oh, provides. Switch. That is also a switch. Okay. we're gonna go into the 17 goes to 0. A firewall which combines a traditional firewall with more advanced filtering functions is also known as a next generation. Stoboroto. Okay. A blank is a device that accesses a service made available by a server. A blank is a device, a client? No, that is made available by a server. A blank is a device that accesses... Oh, yeah, client. What kind of network device is a Cisco Catalyst? That is a switch. And let's go ahead and let's just see a picture of it. Yeah. Look at that bad boy. Look at all those ports that bad boy's got. Ooh. He got ports for days. Okay, what kind of network device is a Cisco? Oh yeah, we did that one. Okay, what a blank monitors and controls network traffic based on configured rules. Firewall. I need to get my AI reading thing. I like hosted my own, like built my own little AI reader for my computer, so that way it's not stuck through the browser. But there's like all these problems with it. It works most of the time, but anyway, a computer network is a digital telecommunication network that allows blank to share resources, that allows servers to share resources, or computers to connect. Nodes, which is nodes. Okay, that makes sense. A blank and a blank are known both as end hosts or endpoints, client and server. A blank is a device that provides functions or services for clients. Server. Routers have blank network interfaces than switches, fewer. What kind of network device is a Cisco ASA? It's a firewall. It's a pretty good one too. A blank is used to send data over the internet. A server. Well, okay. The server has the information. The router is what transfers the information. I understand why that was wrong. Yeah, it's fine. Can a single device be both a client and a server? Correct. A blank has many network interfaces for end user or end host to connect to. A blank has many network interfaces. A switch. What does LAN stand for? Local Area Network. Boom. Let's go. Okay. What does this symbol represent? Router. Good. What kind of network device is a Cisco Firepower? That would be a firewall, because why would it be called Firepower and not be a firewall? That would be stupid. Okay. What kind of network device is a Cisco IRS? That stands for Integrated Service Router, I believe. I think we just looked this up. Yeah, we did. It is a router, but I want to know what it stands for. What does the ISR stand for with... Because I'm pretty sure Integrated Service Router, yeah. This is a client. What kind of network device is a Cisco Catalyst? It's a switch. Yeah. Man, we're knocking them out. Congratulations. We've been through them all. Let's go back to the deck. So what'll happen is that this will reset in one day. So I don't know if we're going to go over these particular cards. The next time we'll definitely go over day 2 when we do that. What we're going to do next is, and remember, if you didn't know already, like we just used Anki. If you just got here, Anki's these flashcards, it's all free. The links and everything are in my video, and my video links. Hey man, Top G, thanks for being here with me. That's awesome. Okay, anyway, the links to the videos that we're using to study with are in the description. And then in those videos is the link to Anki and stuff, which I guess I could probably put in my video as well. But it's in his second video for day 1, the Anki Flashcards, which we just kind of watched. You can download him here, the Anki software. It's a little weird when you download it. It looks strange, but it's totally safe. And then we have the CCNA packet tracers and stuff like that, which is what we're about to get into next. We're about to get into that. This is Jeremy's Tech Lab. That's his website. You can sign up for his stuff in order to get it. And then this is Packet Tracer. So I already have Packet Tracer downloaded. I'm going to open it up here in a second. But for those of you guys who don't know how to do it, I don't know if we'll watch the entire 15-minute thing, but this you just go to Cisco. You go to Netacad, and it should be free, honestly. I bet he has a link to it. Yeah, download Packet Tracer. Yeah, so Cisco Network Academy. Here's the Packet Tracers. There's a few different versions of it. My version might be kind of old. It was from last year. Maybe it would probably do me good to re-download it. So that's where that will be. And then I'll go ahead and open it up. Do the thing. There we go. So in this video, he goes through all the different stuff with it, and you can watch the whole thing, and how to download it and all that stuff. But we'll go over it very quickly in case you're not familiar with it. So we have these routers right here. That's why we just went over all those symbols. So we have the routers that are right here. We have all of our nodes right here. We have PC, we have laptop. I apologize for it being really small. I don't know how to make it bigger. I know how to make it like wider, but I don't know how to make it like physically bigger. Maybe I can figure that out later. Yeah, that doesn't do anything. Yeah, so you can put those things here. We have our components, we have boards, things of that nature. Here's all of our different type of cables. It should, yeah, it's kind of hard to see, but like down here it tells you what it is. So this is a copper straight through, that's a crossover, that's fiber, that's a phone, that's coax, that's serial, that's a different serial, and then so on and so forth, USB. So there are all these different types of things. So if we grab 2 PCs, we should be able to connect it. This is just a normal console cable. So we should be able to connect it to fast Ethernet, connect to fast Ethernet. We just made our first like connection. I wish there was a way. I don't think I can make it any bigger than this. My apologies. Okay. Anyway, moving on. You can open it up. You can zoom in on that. You can see the actual size. You can look at the back of it. You can configure it. You can go to the desktop version of it, These are just little apps that kind of to get you into the terminal, things of that nature, which we'll go all in depth with in the future thing. Right now, we're just kind of like setting things up. Okay, we're not going to watch all of this, but we're going to watch a little bit.
This is a complete course for the CCNA, Cisco Certified Network Associate. In this video, we will look at an essential part of the course, the labs in Cisco Packet Tracer. First of all, what is a lab? In the world of IT, doing labs or labbing refers to hands-on practice with the technology you're studying. Since you're studying for the CCNA, labbing means practicing configuring Cisco routers and switches. There are a few options for CCNA labs. One is to buy actual physical Cisco hardware. real
Yeah, we're not
Cisco
doing that.
routers and
We don't
switches.
have physical hardware.
However, that can be expensive and isn't
Although I
very
do have
convenient.
cables. We'll probably
Fortunately,
make some cables.
Cisco has an amazing tool called Packet Tracer, which lets you set up simulated networks on your computer. We will be using Packet Tracer for the labs in this course. Packet Tracer is free, quick and easy to set up, and lets you create simulated network labs without having to buy any hardware. The network devices in Packet Tracer aren't real network devices.
Yeah, they're just simulated. So we have the lab instructions that are going on here. Like I said, I'm not going to go through all of it. I have his stuff already kind of like in a folder. Where is it? There it is. So here's day 1, lab packet tracer introduction. So this is what he was just talking about. Let's follow along, I guess.
Day 1 lab in Packet Tracer, and let's get started. Note that when you install Packet Tracer and then open it, you will have to log in to your Cisco account again. After that, you should see my lab file like this if you opened Packet Tracer by clicking on the lab file. If not, just go to the File menu and click Open to open my lab file. In my lab files, the lab instructions will usually be on the left or bottom of the screen, and then there will be some devices I've already placed in the network. In this first lab, there is just one router, which I have named the Internet. Then, the lab instructions tell us to place the other devices to make a network. Note that throughout the course, I expect that you will be using my pre-made lab files to do your labs. You are free to make the labs yourself from scratch without downloading my lab files, but that won't work for all of my labs. Some labs in the course require troubleshooting. In those labs, I purposefully made some configuration mistakes, so it's your job to find those mistakes and fix them. Okay, before we go through the lab instructions for this first lab, I want to show you the Packet Tracer Preferences menu. Go to Options in the top menu, and then Preferences. In this first tab, the Interface tab, you can select things like whether or not device model labels are shown. I usually have this off, but if I turn it on, notice that above the Internet, 2911 appears. That is the model name of this router.
Yeah, we'll keep that on because I feel like I need to
It's
know
a Cisco
some of these model
2911
numbers.
router. I just named it the Internet to represent the Internet. I prefer to have device model labels off, so I'll remove this. If you don't want to show the device name, you could uncheck this here too, but I think it's best to leave the names on. Anyway, feel free to check out some of these other settings if you want. I just want to point out one more tab, that is the Font tab. Here, you can change the font sizes in Packet Tracer. For example, all of the menu font sizes, or the font size in the device's command line interface. To make it easier to see in the videos, I set the font sizes fairly large, but feel free to set whatever size you prefer. You can also change the font colors. For example, if you want to feel like you're in the Matrix, change the router iOS text to green, and the router iOS background to black. Then hit Apply and exit. Then click on the Internet router and go to the CLI tab. And hey, now you're officially a hacker. CLI stands for Command Line Interface, by the way.
Okay.
This is how we are going to be configuring routers and switches in the course. Anyway, I'll exit from here, and let's actually do this first lab, which involves recreating the network displayed at 16 minutes and 40 seconds of the Day 1 lecture video about network devices. Here's that network. In the middle, there is the Internet. In this lab, I'm just using a router to represent the Internet. Then there is the New York branch on the left with some PCs, a switch, a router, and a firewall. And in the Tokyo branch, there are 2 servers, a switch, a firewall, and a router. Also, somewhere over the Internet, there is an attacker. Okay, so let's recreate that network. For the routers, the instructions say to use Cisco 2911 routers, the same kind of router I used for the Internet. To place a device in Packet Tracer,
Control
go to the
plus.
bottom left here and click on this icon for network devices, and then routers. Then you can see a selection of router models. Let's select the 2911 and place 2 of them in the network. This is what a Cisco ISR 2911 router looks like, by the way.
Where'd my router go?
ISR is a line of Cisco routers, and 2911 is a particular model in that line. Okay, next let's go to the switches menu here and place 2 2960 switches in the network.
Okay, hold on. I lost my router. Like, I don't understand what happened to it. I didn't delete it, did I? How would I have deleted it? What was the zoom out is control plus underscore. Okay, I don't have my router for some reason. Okay, let's ooh. No, hold on. There it is. There it is. Hey, and it kept my presets. Dope. That's always a good sign. Okay. So what do? We got a switch. We have the internet, and we have router 1, router 0. Hold on. Let's back it up.
Okay, so let's recreate that network. For the routers, the instructions say to use Cisco 2911 routers, the same kind of router I used for the internet. To place a device in Packet Tracer, go to the bottom left here and click on this icon for network devices, and then routers. Then you can see a selection of router models. Let's select the 2911 and place 2 of them in the network. This is what a Cisco ISR 2911 router looks like, by the way. ISR is a line of Cisco routers, and 2911 is a particular model in that line. Okay, next let's go to the switches menu here and place 2 2960 switches in the network. Here's a photo of a Cisco Catalyst 2960 switch, by the way. Catalyst is the name of a line of Cisco switch models, and
we know that. We just did the
2960 is one
flashcards.
model within that line. Okay, next we'll place the 2 firewalls by going to the firewall menu and placing 2 5505 firewalls. Note that in the network diagram in the Day 1 lecture video, the New York branch firewall
Wait,
is
which ones did you use? 5506, 5505.
menu and placing 2 5505 firewalls. Note that in the network diagram in the Day 1 lecture video, the New York branch firewall is between the router and the internet, and the Tokyo branch firewall is between the router and the switch. Depending on the network design, you might find the firewall placed in either position. This is a photo of a Cisco ASA 5505 firewall. ASA is a series of firewalls made by Cisco, and 5505 is a particular model within the ASA line. Okay, now let's place the end devices like PCs and servers.
Okay.
Go to the End Devices menu, and here in the End Devices tab, we can find PCs, servers, etc. So, place 2 PCs in the New York branch, and 2 servers in the Tokyo branch. Then, to represent the attacker in the diagram, place a laptop. Okay, now all of the devices are placed.
Okay.
This isn't in the lab instructions, but let's rename them to match the diagram in the lecture video.
I don't want
To rename a device, just click on the device name. PC1 already has the correct name, so I'll start on PC of the devices. To connect devices in Packet Tracer, click on this lightning bolt icon here. Now, in the next video of the course, we will study different types of cables used to connect devices together in a network. So for this video, we will just let Packet Tracer pick the cables for us by clicking this lightning bolt which says automatically choose connection type. So I'll click on that, click on PC 1, and then click on switch 1. And now they are connected. Then I'll do the same to connect as automatically choose connection type. So I'll click on that, click on PC 1, and then click on switch 1. And now they are connected. Then I'll do the same to connect PC 2 to switch 1.
Yeah, we're not worried about any
Now
of that
here's a
stuff 'cause we're
trick to
still, like,
speed
kinda
things
figuring
up.
things out.
Hold down the control key on your keyboard and click on the lightning bolt. Then I'll connect switch 1 to R1. But notice after connecting them, I don't have to click the lightning bolt again. It is still selected because I held down control while clicking it. So I'll connect R1 to firewall 1 to the internet to R2, R2 to firewall 2 to switch 2 to server 1, switch 2 to server 2, and finally the attacker to the internet. Now they're all connected, so I'll click cancel here, since I don't need to do any more connections. Okay, we're done with the lab instructions. We have successfully recreated the network diagram as shown in the lecture videos.
Oh, okay, that's all we're doing.
Most days of the course will include a packet tracer lab, so you can practice configuring Cisco routers and switches.
Cool.
Ideally, you should try to complete the lab on your own in Packet Tracer after watching the lecture video. Then, you can check my lab video after to confirm your solutions.
Yeah, that's probably what we'll end up
However,
doing.
if
That's
you're
a good
having
idea.
trouble doing the practice labs on your own, feel free to watch each lab video before actually trying the lab in Packet Tracer. That's not a problem. The important thing is that you get hands-on practice with Cisco routers and switches to deepen your understanding of the concepts we cover in the course, and also to prepare for the exam. Okay, that's all for this video. I hope it was helpful. Thanks for watching.
Okay.
Before finishing this video, let me thank my JCNP.
Yeah, all of his channel members. Awesome. Okay, so that makes a lot of sense. I know that this stream was not the most engaging, but we needed it in order to kind of set everything up. I hope that you followed along. You got Anki. I hope you followed along. You're subscribed to Jeremy's Tech Lab. You have Packet Tracer downloaded. You're ready to do things. On Wednesday when we come back, what we're gonna do is we'll watch the lecture video, and then we're gonna do the Packet Tracer and we're gonna do the cards. We're probably not gonna watch the entire video like how we did today. We might, but we'll definitely watch like certain parts of it because we're gonna go over wires, and I always have a lot of questions with like the connectivity and like how all that stuff works. But we'll definitely do the flashcard, or we'll definitely do the practice questions, flashcards, and the Packet Tracer, and that's what's going on with that. So anyway, I will figure out all of the stuff to make sure that we don't have any issues with OBS like we did today. Other than that, we're done. We're not going to do anything else. I will see you guys on Wednesday. Oh, streaming tomorrow. I'm playing Gears of War on the gaming channel on ParaDiddlePete. So if you guys are interested in that, I'm playing the original Gears of War because E-Day is about to drop. So if you're interested in that, you want to watch some gameplay or whatever, come on. Yeah. Other than that, I will catch you guys later.